Hey guys, chapter 26, number 39 here. Question, it's given us three charges, two negatives and a positive, and it tells us we're most interested in the negative 10 nanocoulomb charge. We need to find its magnitude of the force that it's feeling and the angle of measurement with respect to the positive x-axis. So for ease of this problem, I've assigned negative 10 nanocoulomb charge to be guy number 1, negative 5 nanocoulomb charge to be number 2, and the 15 nanocoulomb charge to be number 3. Right away I see we have two distances. It's 1 centimeter. I converted it already to 0.01 meters. This guy was 3 centimeters, converted to 0.03 meters. I see there's two like charges here, so the force that 2 is applying to number 1, the one we're interested in, is going to be away from it. It's repelling it. Two like charges due to Coulomb's law repel. And we have a positive charge up here and a negative charge over here. And Coulomb's law says those will attract. So F of 3 on 1 is going to be towards the positive. So those are the forces we see. This force I see only has a y component, so that'll be an easy one to calculate for us. F of 3 on 1, however, will be a little bit more difficult component to calculate because it does both have a x and y component. It'll just take a little bit more work, but I know at some point we're going to need that angle, so I'm going to start by solving for that angle. So when the time comes that we need to split up component-wise, this will make our lives a lot easier. So we have tangent inverse of opposite 0.01 over adjacent 0.03. And that'll give us a theta, and theta in this case is going to be 18.43 degrees. So now that we know E is 18.43 degrees, let's start with the easier of the two forces. We'll do F of 2 on 1, and using Coulomb's law, F of 2 on 1, we're going to have K, absolute value of Q1, absolute value of Q2, all over a radius squared. So 9 times 10 to the 9, we're going to have Q1 be 10 times 10 to the negative 9, absolute value. We drop the negative in front, and that'll be coulombs. And Q2 is going to be 5 times 10 to the negative 9, again coulombs, and we drop the negative. And that'll all be over a radius of 0.01 meters squared. And our resulting value from this is going to be 4.5 times 10 to the negative third in the j hat direction, or y direction. However, we know that it's going down because of the visually here in Coulomb's law. And so we'll apply a negative there to show that it's going in the down direction. So that's F of 2 on 1. So now we'll work on F of 3 on 1. A little bit more complicated, but we can find the net charge, or the net force on this diagonal charge. And we're going to do the same thing. We're going to have K, absolute value of Q1, absolute value of Q3, all over a radius squared. We know K, 9 times 10 to the 9. We know Q1, again, is 10 times 10 to the negative 9 coulombs, and we know Q3 is 15 times 10 to the negative 9 coulombs. The radius here is the hypotenuse of this right triangle, and we will get 0.01 squared plus 0.03 squared. Typically the hypotenuse is going to be the square root of it, correct? But this r squared value is going to cancel that out, and we're going to be left with just that radius. So the answer to this then, to this diagonal force we're going to get, is 1.35 times 10 to the negative 3 newtons. However, that's the diagonal force. That's not component-wise in terms of I hat and j hat. So we're going to go out here a bit, and we'll go up to here. So now to get the x component of this, or the I hat direction, we're going to use that angle we found earlier, that 18.43 degree angle. So we're going to have 1.35 times 10 to the negative 3, that force that we've just found, and we're going to multiply that by the cosine of 18.43 degrees. However, we know that this vector, this diagonal vector, is going up and to the left, and because of that, this cosine is going along the negative x-axis, so it needs to be a negative, so we'll apply the negative there. So the x component that we solve for then is going to be 1.28 times 10 to the negative 3, and that'll be in the I hat direction. The y component that we solve for in this diagonal, the j hat, is going to be same thing, 1.35 times 10 to the negative third. This time it's going to be a positive sign because it is going in the positive y direction. When we solve that, we get a value of 4.26 times 10 to the negative 4, and that'll be j hat, that'll be positive up direction. So now f of 2 on 1, we saw earlier, had a downforce, a negative y direction. We have a positive y direction here. So I'll bring that back in right here, and this is f of 2 on 1, and for reference this was f of 3 on 1, this value. So f of 2 on 1 was negative 4.5 times 10 to the negative third j hat. When you add those two up, add these two values up, both your y hat direction or j hat directions, your y directions. When you add them, you get a resulting value of negative 4.07 times 10 to the negative 3. So it seems about right. A small vector going in the negative y direction, our resulting vector. So that will be that one, that'll be the j hat direction. And we already know there's only one value going in the I hat direction, the x component direction. So with that we have negative 1.28 times 10 to the negative third that we just solved for. So when we draw this out here, we have this charge going down, that's the only charge we have left, in the j hat direction, which is negative 4.07 times 10 to the negative 3, and we have a charge going in the negative x direction, which is 1.28, negative 1.28 times 10 to the negative third. And when we get this guy here, this hypotenuse is going to be the magnitude of the charge. And using Pythagorean theorem, we're going to get, I'll leave the math up to you guys, but we're going to get 4.26 times 10 to the negative third newtons. So that's the magnitude of the force. Still need this angle though. The question asks what the angle is from the positive x-axis being right there. So we're going to ultimately need to find this angle. But first we need to find the theta here. So tangent inverse of opposite, negative 4.07 times 10 to the negative third divided by negative 1.28 times 10 to the negative third is going to give us theta. Theta is then going to be 72.5 degrees, and 180 degrees minus that 72.5 degrees is going to give us our resulting value. (180 minus 72.5) is going to give us our resulting angle, the final angle that we're asked for, and that's 107.5 degrees, and that's going to be clockwise from the positive x-axis. So with that, we have the 107.5 clockwise degree angle, and we have the final magnitude of the force that the number 1, the negative 10 nanocoulomb charge is filling, is 4.26 times 10 to the negative 3 newtons. And with that, thank you.